All right.
Just
Okay.
introduce
So,
your talk, and then everything will go.
okay. So my name is Ali. I'm also known as Christine. Um. So I guess you can ask questions about me later, but I think for now we can just move on with the talk. So one warning I have to give to you is that my whiteboard is not working. So you guys will just try to memorize the problem or take a screenshot or something because I won't be able to put the problem up with the whiteboard because it's not working. So that'll be kind of annoying. Yeah. So we're just gonna do some problems today. It shouldn't take too long. It's not like high key at all. So I have a couple of Amy problems and a couple of Olympian problems. So yes, this is me. Oh, I should have changed this to 19th hour. Okay, so this is the first one. It's pretty classic. I would be surprised if a lot of you saw it before. And I'll give you like maybe I'll give you like 3 minutes to try it, and then I'll talk about it. Oh, also I should talk about like what the theme of this talk is. So it's called meta solving. So the idea is that there are some problems which can be solved easier because you know that they're on a contest, or they're like problems 5 on the Amy, so they shouldn't be too bad. Or like problem 1 on the contest, you shouldn't be too bad. So like those kind of problems. So that's what this talk is going to be about. So yeah. So this is the first one again, and I'll give you 2 minutes to solve it. Well, at least try it.
Okay, if you've just arrived, and I think there are a few of you, you guys should just try to do the problem that Ali is currently presenting.
Yeah. Okay, so the 3 minutes are up. So yeah, so let's talk about this a bit. Okay, I can't like see the chat or anything, and no one's gonna talk, so I'm gonna have to change the chat. So did anyone make progress? For people who haven't seen this before. Oh, wow, people are silent. Hey, we should talk. We should talk. Sophie Germain identity. Oh, yeah, that's a great thought. That's actually the first thought I had when I looked at this problem again. I was like, look at those powers of force. I think it's Sophie Germain identity, but actually the thing is it's not. So it's something a little more nuanced than that. So I think, yeah. Does anyone have any other ideas? Factor. Yeah, factor. So like, basically my point here, I think this is kind of the most low level one, which is that like, since it's on Amy, and Amy is a fairly, Amy is bashy, but I don't think they want you to multiply like 6 for 40 years. So the guess is that so it's a factor. So so you want to look for a way that's factoring. So that's kind of the point here. And basically what you want to do is that so you have a lot of expressions that look like this: x to the fourth plus 324, right? And now 324, like, because if you wanted to, right, it has to look something like that. And this is like, I don't think it's in that form. So for your main identity is no. So you can't do this. No. Sad face. Okay. So we're gonna have to do something else instead. And actually, if you know the way in which you derive Sophie Germain, you can actually do something quite similar. Like, so Sophie Germain is it's like something like this, right? A to the fourth plus, oh god, writing with a mouse, so many grades, equals like a squared plus 2b squared minus 4a. So this is how you derive Sophie Germain, right? You get this. So you kind of, you almost like complete the square, except not. And then this is a difference of squares, so it factors like instantly, right? Like you guys are all familiar with difference of squares, right? Talk, people.
I'm all familiar with it. Don't worry.
Okay. You guys are so quiet. I've never went in a classroom and the people are so shy to talk. What have you guys been doing to them? Jesus. Okay. So yeah. So like this. And you know the other kind of, well, okay, so this is equal to, see, I wish people would talk. I hate this. I feel like I'm just talking to a wall. Right? Ta-da! Amazing. So actually Sophie Germain is kind of a step in the right direction because it's the same idea. So and then this instantly factors. So and then like just stuff like just cancel on. That's what I wanted. Oh no. 6x plus 8. So like plus or minus. Horrible notation, whatever. Okay. So that's kind of the idea there. So yeah. So that's our first problem. Let me clear this. Did anyone get it? Does anyone like not get it? No, like, why are people so silent? It really makes me uncomfortable. Okay. So yeah, that's the thing. Okay, I hope that made sense. I don't know how to clear this. Oh, fun. So I think the next problem is like the most accurate to the same because I actually struggled with finding problems that match the same. So the next one is, oh, that's not it. Okay. So this is the next problem. This is the number 13. So it's fairly hard, but it's on the Amy, so it can't be that hard. Well, like, it can be solved in 10 or 20 minutes. So I'll give you guys like, this one's tougher. If I give you guys 2 minutes, you might be more likely to get it than if I give you like more time. Here, I'll just like give you 2 minutes. I don't want to think about this. So, oh no, not an hour. All right. Go solve. All right, so it's been 3 minutes. So, as before, I'll ask if anyone has any ideas. Unless you think you solved it, then there is not much of a point. But I want to get to see if there's anyone who has some ideas about what to do. Factoring. Okay. Shut up, Vincent. Okay. Try to find A3 and A4. Bound AN. These are all good ideas. And in fact, if I actually had like 30 minutes left and I was doing number 13, I'll probably do one of these. But if you have 2 minutes left and you have this number 13 in front of you, the better way to do it is just to be like, wow. So the sequence, so these are positive integers. And somehow you have that an plus, okay, great. Let me write the sequence so you guys can all see. Okay, because I don't even remember this. An plus 2 equals 2009. And, oh my god, my handwriting is so bad. An plus 1. What a coincidence! That for literally every n, for like n all the way to infinity, this one divides this one. That's kind of weird, isn't it? Right? Like this is like too much of a coincidence. Basically, what I'm implying here is that A is probably periodic because like you have numbers stretching off into infinity, all of which seem to satisfy this random property. Like, come on, it's periodic. So, so it's this very like smartly discovered fact of mine. We're like, okay, if it's periodic, oh my god, my circle is so bad. Why don't we try? Oh my, no, it's bad. It's still bad, but it's better. So why don't we try like? Why don't we say if there's a period 1? So like let's try just like okay, did that like previous reasoning make sense? Like it's not rigorous, but just saying, it's kind of an awful coincidence. Yeah, it's just like a whole lot of a coincidence. So clearly it's periodic. Oh, people I know are on. And so you can try just seeing if it's a period 1, but I think it just doesn't work out or something like that. Anyway, 9 A1 1 A1. Let's see what this can do. Oh, this makes A1 squared equals 2009, so that just doesn't work. Right, because 2009 is not a perfect square. Okay, so this one's out. Period 2. Someone says,
Ali, if you're writing something on the whiteboard, we can't actually see it. I think it's lagging.
Wait, is it what? Can you see my, like, can you see?
Can you go back to the whiteboard
right?
for a moment?
Yeah.
You're cutting out, like, and lag. Okay.
I just finished the period.
Okay, gotcha. Can everyone else see in the chat whether they were able to like see the whiteboard like working for the last moment? Because yeah, I think it was.
Oh,
but now it's working.
Lagging?
Yeah, it's like.
You want me to like lower that part again?
We couldn't see what you were writing, but it's okay. I think it's working now. Just go on. Sorry.
Okay, so like I just go over what I just did. So the guess is that it's periodic. And if the period can be 1, like you can't because that require like if you just do the math, it just requires that A1 squared is 2009, and 2009 is not a perfect square. So yeah. So it turns out the positive integer part is pretty important for this. So then your second guess is like, well, what about period 2? So that would mean like, well, first you need this. Great. This is A1. And I need like A4 equals 2009. A2. So these are your 2 conditions here for period 2. A2. And then if you multiply this out, you get A1, A2 equals 2009. And same thing here. Now, like what the question was actually asking for, if you remember, was the maximum possible value of A1 plus A2. So if you want to maximize A1 plus A2 when their product is fixed, are you guys like familiar with AMGM? Because I know. Or like I can't explain it, but like like.
Everyone's familiar with it. They all did inequalities week. Okay,
so basically the idea is that like as these 2 get close to the geometric mean, the sum should well, they wanted the minimum. Sorry. So as they go to the geometric mean, then sum should decrease. So you want to find it really close to the square root of this guy. So I think that turns out the closest pair is like 41, 49 or something like that. So your answer is 90. And then if you want to ask like, and then you're like, what about period 3? Well, period 3 is too much work, so we just won't do that. And I think if you were gonna do this rigorously, I think the method is something like this. I don't really do this, so I'm not very familiar with the rigorous method. I just think it's funny to like guess things, and then it turned out to be right. So let's erase all this. Of course, you could try like period 3, and I bet like you would get something like that wouldn't really help you much. Probably would be lower. So let's see. So I think the idea is that like basically it's a ton of like algebraic manipulation, and then in the end you get something like if you have a sequence dn defined equals like an plus 2 minus an. I didn't really do this. I can't really for you how to do this. But, and then you get something like if you do like a bunch of manipulation, you get something like dn plus 1 equals dn over. I think it should be like an plus 2 or an plus 2 plus 1 or something like that. So something like this. That's what ALP is. So and then I turn out these differences just go to like 0 or something like that. So yeah. So they have to be 0. Well, but like they're like an like if you assume they're positive, then this eventually becomes like non-integer, which is a problem. So actually, it's kind of the same reason as I said before, just that it's a bit too much of a coincidence to have all these things dividing each other. Of course, this won't always work, but like if you have 5 minutes left and you have to do a number 15, you know, you can do this sometimes. But that's the second problem, and then so yeah. All right.
Ali, there's a quick question.
How do you know the period is extremely large? Well, you just hope it isn't. Like, that's too much work, you know. Like, this is kind of more like, yeah, like wishful thinking, right? You're like, oh, I have 10 minutes left. I have this number 16 I have to solve. And hey, it's probably periodic, so let's do that, you know? So, yeah. And I think this kind of thinking would help you a lot on, like I think like I was almost gonna put the online AIME number 6, but then I realized probably lots of you already saw it because you took the test. So, yeah, I just left that one out. But this one's kind of like a replacement. Okay. So next problem. And I'll give you a warning that I was trying to pick problems that fit the scene well, but it turned out it's kind of hard to find problems that you can just guess. So I'm just trying to get something closer. So this is kind of an Olympiad problem. So I guess I'm familiar with like these questions, or should I just like should I skip this? I have enough time to skip this actually.
Yeah, you're familiar with it. Don't worry.
Okay, so oh my god, no. So yeah. So you can like play with this for a little while. I'll give you like 2 minutes. Because I was scared I was gonna run out of time, but I mean not be able to fill up time, but I guess it turned out well actually. So I'll just and I don't think there's like much value in it. So I'm thinking about this because it's a cool forever. So 2 minutes starts now.
If you've just joined, feel free to try and solve the problem that is currently on Ali's screen.
Okay, so that was 2 minutes. So I guess like, so yeah, I think this one's kind of hard. So does anyone have like any ideas or complaints about how weird and difficult this is? That was definitely how I felt for a while. They could all be 29. Wait, yes, great idea. Yeah, so sum up all the equations. This doesn't work well because you don't know the signs. Like, if you read the problem, they can be in any, oh, frick. Why is clicking so hard? Okay, they can be in any order, right? So in some order, arrangeable, right? So like, this is the thing that I found the most wonky about this problem is like, well, what do you mean you can put them in any order? Like, it doesn't give me any information at all. Well, actually it does. Radical access theorem proves concurrency. Great, great idea. Yeah, I think that's it. You know, let's come on, let's do it. Let's do some radical access. Yeah. Okay. Okay. No. Yeah, that's a good idea. That's like a start, right? Because 29 works. Everything is 29 works. So I think basically what I realized after maybe 2 or 3 hours of trying this problem was that like it's too hard to deal with any order. So the way to do it is to get rid of the order, and the way you do this is by taking a mod 2. So like write A plus minus B plus C minus D, right, plus E. So this thing is icky because you can switch these around. But when you take it mod 2, it's equivalent to A plus B, right? Because -1 is the same as 1. So plus C plus D plus C. So this is like too hard. And then this is like much better. Even though it's mod, so this is mod 2. Wait, let me stress this. And I should get rid of the circles too. Yeah, so once you get this, it's not that bad. It's because you know that basically the sum of any 5 consecutive numbers is equivalent to like 29 or 1 mod 2, right? And then this forces all of them to be like odd for like reasons. Like basically if they were like, because 2017 isn't like a multiple of 5 or something like that. Basically they all have to be odd. And then the coolest thing you can do is that like, so you send A to like, oh my god, let me get rid of this. So you send A, so you replace A with like A minus 1 over 2. So let me make sure I got why. Oh yeah, wait, I remember now. Okay, wait. No. Let me explain to you legitimately why they have to all be 1 mod 2. So basically, so any consecutive term, so 1, 2, it can be 1, 2, 3, 4, and 5 instead of like A1, A2, A3, A4. So these come to 1, right? And then 2, 3, 5, 4, 6 also come to 1. So 1 and 6 are equivalent mod 2, right? Because these things are the same. So these two are the same. So 1 is the same as 6, which is the same as 11, etc., which is the same up to like 2016 or whatever. And then because it's a circle and 2017 is not divisible by 5, like it wraps around. So then you get this is equivalent to like 1, 2, 1, like 4 or something, I think. Should be the same as A4, same as 10, same as A9, all the way up to, you know, and then basically you get all of them have to be equivalent. And if all of them are equivalent, then all of them have to be 1 because you have 5 of them. Right? So that now your main obstacle is out of the way. Does that make sense? Yeah. Okay. Sorry. I just forgot how to figure it. I was gonna hand read it, but then I realized I probably shouldn't because it's kind of important. Yeah. And I think to summarize, basically the main idea here is that we take it mod 2 because this is too much work. It's too much. All right. So yeah. Any questions? No questions? Okay. I'm surprised that there are no questions. If I were you, I'd be asking questions. Okay. Whatever. Let's move on. Really, no questions? Okay, you guys are really quiet. Wow. Right, that's what it is. So now you know that they're all equivalent mod 2. And then basically you're like, well then what about if they're all equivalent mod 2, right? Then that means A1 is equal to 2B1 plus 1, right? And then like for some B1, and then like, just AI is equal to 2BI plus 1, right? And then this actually is this property, right? Because if you have A1 like minus A2 plus A3 minus A4 plus A5, right? You can just replace this with like, what is it, like B1 minus B2 plus B3 minus B4 plus B5. And then this is like, what would it be like? And this would be mad one. So this is like 14 or something like that, right? But you had the same problem again. So what you can do the exact same trick, take mod 2, and then everything's even this time. And then it becomes like C1 minus C2 plus C3 minus C4 plus C5 is like 7. And basically you do that until you get like 0. And then when you get 0, like basically it implies that like if you just keep doing it, because you have to be able to keep doing it. So then like there's like some, oh my god, I'm sorry. What implies, oh yeah. So the sequence is 0. And then you can just like work backwards and get like, you can get the original thing. So yeah. Because here, let me explain to you why when we get to 0, it has to be 0. So basically, wait, does this part kind of make sense? At least like where we reduced it from 29 to 14. Let me check. Yeah, so you just descent, right? Infinite descent, blah, 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 whatever. So, sorry, that's my cookie barking. Okay, let's get rid of this. There's no question. Just press. Am I not good at explaining things? I'm pretty sure I'm pretty bad at it. So, okay. Okay. So final step. So I just want to convince you that if you have everything adding up to 0, it should be 0. So let's say we have a sequence x1, right? And then every 5. In some order, it's fine. So basically the way you do this is that this means every one of these elements has to be even, right? Based on what we did before. If you take a mod 2, then you have to get every one of them even, right? But then replace x1 with 2x prime 1, right? And replace each with x prime. Then you get the same thing. So they have to be divisible by 2 again and again and again and again, which isn't possible unless it's 0. So they have to all be 0 by the time you do this. And then you can just literally like work backwards and you'll get 20. You get everything as 29. So yeah, that's how you do this problem. Does it make sense? So quiet. Okay. I'll just assume that it did. Yeah, like I've never given a talk and I literally have had 0 questions like this. Like I'm definitely not as good at explaining stuff. So I'm like really, really surprised. Yeah. Like I don't really understand it. Yeah. Okay. So that's 27 API number 1. Okay. So I guess no one has any issues. So let's move on. And then this one. So I don't know if you guys saw the API analysis here because it was written by one of my friends, but I tried it. I looked at this problem. I tried it for half an hour and I gave up. So this problem's, I don't even know what to say. This is such a bad problem, but I'm gonna give it to you anyway. So if you guys have seen it, don't spoil it, please. Yeah. 3 minutes starts now. The dogs actually. Yeah.
Allie,
Yeah.
I'm a little confused. Yeah, why is 2 foolish?
It's 2 not full. Wait, did I like mistype this?
Yeah,
2. Wait, let me make sure I didn't make any typos when I do this, because I might have copied this by hand.
yeah, I think it should be 3.
Oh, did it mean 3? Yeah, wait, it might be 3. Yeah, actually. Shut up. There's like a. Okay, let me go find it. Sorry. And then meanwhile, just like.
I think the problem statement is correct.
Oh, geez. Stop. It's not what I wanted to do. Oh, there. That's the button. Yeah, sure. Yeah, it should be 3. That's the only. I think that's the only typo. Yeah, I'm just bad. And you guys have like 10 seconds left, so choose. Okay, so time is up. So, any ideas? 3, yeah, 3 is foolish. This is such a fun. Okay. Yeah. So let's talk about this. So you can. So if your idea, I think, because I had an idea like Andrew, which is that, well, 3 event is much bigger, so the sum of those things should be bigger, right? But like, of course you can like, let me erase this. So if you have like, for example, like, because you can have powers of 3 really, really close to powers of 10, right? Like, of course, like, you can say like, oh, they can like pretty close, So like, I don't like, that's kind of the at least that's like the first kind of suspicion I'd have as an argument, like 3 to the n is bigger than 2 to the n. N must be a multiple of 3. I think this is right. Yeah, I think this. Yeah, multiple of 3, right? Because kind of seem much. Yeah, okay, that. I'll just go with that. I don't actually remember what the condition is. There's some like mod condition. Basically, that I like, cause the sum like. Yeah, so the thing is like, for sum of digits, like I think the kind of 2 things that I can think of off the top of my head that work on it are like size, right? Which, as I said before, probably doesn't work, but it might. And then the other thing is like mod stuff, right? But mod stuff doesn't really help because you have to. It's not only just like 1 underneath it mod 9. It's 1 underneath it, like, period. So like that's why I'd say like most of those don't work. And at that point, I just gave up, and I said I'm not going to take the APF on those. Yeah. See, like you're like, well, and also like you think after 3, like the number get really big quickly, and you're like, can there really be other foolish numbers? Well, let's try, right? Because if anyone has any other ideas, like the 2 kind of angles that we can approach some of the digits kind of don't work. So we can let's just like just try and see if it works. So let me like make sure that the mod things are right. So it has so when n is bigger than 2, then the sum of digits of, let me like call it S or something. Sum of digits of 3 to the n, oh, just so that, is 0 mod 9, right? Okay. So then sum of digits of 2 to the n has to be 0 mod 9, right? Has to be, no, not 0, negative 1 mod 9. And sum of the digits is equivalent to the actual number mod 9. So, right, this is true, right? Okay, so I'll just remove it. If it's not true, someone point it out. It's a sum of the digits. So the sum of the digits is equivalent to like the actual number mod 9, as far as I remember. So, so this is equivalent to 2 to the n. So if 2 to the n is negative 1 mod 9, and by like some variant of like Fermat's little theorem, we have like n is equivalent to 3 mod 6. Right. And then the reason why this doesn't work for n equals 1 is because you don't have this thing being true yet, because n is not greater than 2. So you get this, right? And we can try. So we know that n equals 3 already works. What about n equals 9? So 729 times 27, but like I think I remember this, like 1 9. Let me like get a calculator. I'll make it, because of course you're not supposed to use calculators, but yeah, I don't want to like have you guys like hang up. Try this again. No. Okay. 3 to the 9th. Yeah, 19683. So, and then this guy's pretty big, right? So this is like 9 9. So this is 27, and then this is 8. Right. So it works about 9, but it doesn't actually work. Next thing we can try is n equals 15. So 2 to the 15 is like 3 2 7 6 8. Now, I actually don't know 3 to the 18. I mean 3 to the 15. So I'll calculate that right now. 3 to the 15th power. Okay, it's great. This guy. 2 4 8 9. 26, yeah. And this is like 9, 20. This is 36. So again, it works out one line, but doesn't actually work. Right. And at this point, you're like, why would I try to do another one? Well, because you have no other idea what to do, right? Because like, okay, like we already talked about this before, like proving the actual problem seems really hard. So the other avenue is to see if stuff will work. And this should be the good one. So I actually don't know what 2 to the 21 is anymore. So okay, it tells me, oh, how do I move this thing? Oh, I can do it great. 2097152 and 10 26. Okay, this is 26. And then 3 to the 21 is 104605 3 5 3 2 3. Yeah. Okay, so 5. This is 5. This is 11. So that's 16. And then this is 11 again. So this is 27. Boom. Yeah. So it turns out n equals 21 works. This is just such a bad problem. Yeah. So yeah, are there any other? So that's what I was asking. Are there any other foolish integers? And the other one you can come up with easily is 21. Yeah. So this is just such a like I actually didn't get this problem. This is a problem that made me just like I don't want to do this one. Yeah, this is too hard. So yeah. So okay. So my talk is done. Those are the 4 problems I had. It actually ran for quite a while, so I'm surprised. Although 10 minutes of that was just me like finagling this tech. So yeah. Okay, so I guess I'm supposed to open it to questions, right? So that's what I'm supposed to do, right? Okay, so if you guys want to ask me any questions, I'm up for it. to make up for your lack of question asking throughout this talk, which is quite depressing. Either combo. My favorite topic is either combo or geo. It's definitely not NT. I just hate NT. Like you can see why I hate NT, right? It just sucks. Or calcs allowed? No. Am I in contention for IMO 2021? Currently at this moment I am, but I suspect that there is a decent chance after TSTST 2020 that I will not be. I am not a child prodigy, and the chance that I actually make IMO 2021 is quite bad because my level is like nowhere near IMO. Ali Sai or Christine Yang, but I don't think that's what you're asking about. There's a chance. The chance is like about 0. Honestly, I kind of suck at math. Yeah. My ninth grade, like, was it worse for regards to what? Like math or like in general? Everything will be fine in the end. I am Ali Phoenix. Yeah, I am Ali Phoenix for me. Yeah. So this was like kind of a long one, but whatever. I guess I'm not that famous yet. Summer programs. So I attended MassPass when I was a rising 8th grader. I attended Awesome Mass when I was a rising 9th grader. And I attended Mass Camp in addition to MOP last year. But I'm not attending any summer program this year. So yeah. I got rejected from Spark. Interests outside of Mass. MassPass. Yeah, it was pretty fun. I think it's one of interests outside of math. Oh, you already know this, bro. I like playing anime songs. I like anime. I like manga. Interests. Oh, what other interests? Oh, I like writing, and to some extent I like reading. I don't really get around to it. Do I recommend Mass? It was pretty good for me. Like I don't think I fit in there great. I'm not like that one. I'm not like those people who like Math Camp was life transforming because MOP was life transforming for me. But it was pretty good. I enjoyed it. I got to meet some cool people. So like I mean it's fun to go to, yeah. But it kind of also depends on your personality, I think. What do you think my 12th grade self will tell me? Try harder. Yeah. But like the nature of this is that like, right, like, oh yeah. So this is hilarious though. So last year I got 27 on JMO, and I was 1 point off of HM, and I made MOP because I'm a girl. And then this year I got 27 on JMO again. Like my distribution on day 1 was literally 453. So yeah, and then I got 27, and then the top 24 cutoff on JMO was 28. So I saw I'm gonna be 1 point off of HM, but then they took more HMs, so I don't know what they're doing. How to make MOP? Be a girl. It was pretty good. I didn't like actually go to IMO for the pandemic, so I don't think I can really speak for that. My goals for next year: learn programming, stop being so lazy on math, get to know people at Andover. Yeah. Oh yeah, do you want to hear a funny story about EGMO? See, you guys are even. I have to like fill this up for a second. You talking. So I got a 4 on problem 1. By the way, I got a 4 problem 1 on EGMO, and I also got a JMO. So don't be like me. So I got a 4 on problem 1 because I screwed it up. Like I screwed up the write up really bad. Like the idea was totally correct, but I screwed up the write up. So and then I told the team later that I wanted a 5, but she wouldn't give it to me. And then it turned but not for long in history.
Ali, you just cut out.
Okay.
Do it again.
Oh, did I cut out? This is sad. I was saying that I will not be an ECMO silver medalist for long. I'm not sure what this is supposed to mean, but yeah. Circles are intersections. Oh yeah. Can we like not talk about circles? Have one intersection, not two. They have one. Yeah. Yeah. Invert them. But the question is, where do you invert them? Because even if you invert at a random point, you'll still get 2 circles that intersect. So clearly the solution, I don't have one. I actually remember, I like just don't remember problems. Like people, like I know some people who can just recite, like if you're like IMO 2008 number 4, they can just tell you the problem. I'm not on it. I like forget problems in a week, so I like Barry though. Best week of my life. Damn, this is a hard one. I think the 2 candidates all happened within the last year. So like either like the last week at MOP, maybe the last week at Mass Week. I don't think so. The last week of MOP, or maybe the week I spent in the East Coast this fall, because I was touring private schools. So then I visited MIT, which is super cool, and I talked to people, which is super cool. So those are, yeah. So I guess those are my 2 contenders. I don't know which one's better. They're different. Yeah. Programming. Definitely programming. Yeah. Like when I was little, I liked programming better than math. But then I started doing math because I don't know. Yeah. I play piano. I used to play classical music with a teacher, and I quit. So I play anime songs. And then I also tried playing cello a bit, but I really suck because I don't practice. Yeah. Okay. Yeah, it's fine. Well, sorry for also like not. Well, today has been like pretty busy so far, so I didn't get time to review because I'm bad. I didn't review the questions, so I wouldn't have this weird moments like, wait, actually, I should explain this more. But yeah. Oh, I have a question for you guys. How is Everest? Do you guys like it? Well, like for the people who like are going to Everest. Wow. So you guys have nothing to say about your Everest experience whatsoever. I bet Andrew's pretty sad about that. Oh, that's good. Yeah, that's what I expected, honestly. Because when I reviewed the handouts, I remember telling Andrew like, "This is too much. You can't give them this much work." Oh, whatever. Yeah. Well, maybe I'm just underestimating you guys. So, yeah. But like on the other. Diego, where do you live? Which country are you from? Mexico? Oh, that's cool. I remember Mexico does pretty well at EGNO or something like that. Oh, sad. Oh, yeah, also, another funny story. I guess I have a lot of these funny stories. So in 8th grade, I failed the Amy, and I didn't make JMO. So in 9th grade, then I made JMO, and then I got 27 on, so that was pretty cool. So you guys can bounce back. Just don't be like me and be dumb. Are there any girls here? I see an Ivy thing and a Jennifer one. You two are girls, right? Olivia Shu. Is it ratio? What's the ratio here? I have 1, 2, 3, 4. I guess altogether at least 4 girls. But some of the names I can't tell. That's cool. Yeah. Okay. I have to go eat, so I'll probably sign off now. If you guys want to talk to me, you can message me on Messenger. I guess I have time, but not
Thank you
now.
so much. Okay, really appreciate it.
Okay, cool. And yes, so I'm leaving. Bye, guys.
Bye.